Good evening, everyone. This time we're going to study 8.3, testing about a mean. In 8.2, we did testing about a proportion, remember? Proportion. Today we're going to study testing a claim about mean. And like last time, we're going to use this wording of conclusion. We call this is a case. Remember this one? We did first box is case 1, case 2, case 3, case 4. Okay. So we're going to use this procedure to find which case we will end up. So now let's look at the testing a claim. Now we're going to do sigma not known case, okay? There are two cases, sigma known, sigma not known, sigma known. We're not going to cover sigma known. We're going to do sigma not known. Okay, let's look at the question right away. Example here. This is number of hours people sleep. There are 12 people. We ask them, how many hours do you sleep? Okay, the author of times of sleep. It is randomly selected, okay? You don't necessarily select college student. You don't necessarily select seniors. Just random, okay, out of population. So when they pick 12 people, so first person said, I sleep 4 hours. Next person, 8 hours, so on and so forth, okay? And then when you put this in L1, the mean, the average was 6.833, as you can see here. And the standard deviation was 1.9924, as you can see here. Okay. Now you can put these numbers in the calculator, and then you can figure out, you can compute that mean and standard deviation. I'm talking about these. If it's not given, they are given here, but sometimes they don't give it to you, then you can calculate. So here, so I put stats, edit. Remember this one? I clear L1. I put all the numbers, 4844, 4844, 8697, 8697, and then 71078, 71078. So you enter those 12 numbers, and you go to stats, calculate one variable stats, second L1, list 1. So if you see, do you see that X bar is 6.833, the first one? And then SX, that's standard deviation, 1.9924, okay? So you can actually compute those from the calculator, even if you don't have X bar and S, okay? Why we need that? Because we need that to compute test statistic. Okay, now, so this is the claim. Test the claim that mean amount of sleep for adult is less than 7 hours. So from this data set, can you say average number of hours people sleep is less than 7 hours? We're going to test that claim. So let's do that like last time we did. Okay, so let me get the okay, here. So now, so let's just move it over here. So let's do that, okay? Let's the claim. So claim is, let me just make it a little smaller. Okay, so number one, 7 step. Okay, 7-step test. Okay, so number 1, the mean is mu is less than 7 hours, less than 7. So because there's no equal sign, this is case 3 or case 4. What I mean by that? In the wording conclusion, we're gonna go either case 3 or case 4. You're gonna pick either this box or this box. Why I go there? Because original claim does not contain equality. See, mu is less 7. No equal. Okay. If mu is 7, then this is equal. But it is no equal. No equal. Okay. So that's why we have to go here. Then it's going to be either this one or case 4. Okay. Anyway, so let's go back to, let me erase that. And then go to textbook. Okay. So now, so using that, okay. So now, so case 3 or 4, number 2, the null hypothesis, the 7th step, follow this, is mu equal, null is always equal. Now, H1, what is the name of H1? Alternative hypothesis, is less than, same as the claim. Well, I have to say the first one. I should say claim mu is less than 7. So this is case 3 or case 4, and this is same as H1, and claim is the same. Okay. Why same? Why same? Because claim has no equal sign. Okay. Now, number 4 is test statistic. Now, in 8.3, test statistic is T. It's not Z. The formula is X bar minus mu divided by S divided by square root of N. What was X bar? The average. What was average it came out? X bar was 6.833. S is 1.9924. N is 12. Okay. And then mu is 7. Okay. You put this in the calculator. So X bar is 6.833 minus 7, and then S is 1.9924 divided by square root of 12. Okay. So if you put that in the calculator, I'll just put that in the calculator here. All right. So 6.833 minus 7. I hit enter, divide by, you gotta put parenthesis, 1.9924 divide by square root of 12. And you have to put parenthesis once and 2. And when you enter, you get negative 0.29. That's close enough. 0.3. Okay. So if you, I think a textbook may have done that. Do you see that? Negative 0.29. Okay, you see that, 290. Okay. So now what are you going to do with it now? So we have to test the claim. So first, I'm going to use, we have 2 ways to do it. Okay, number 5, p-value method. P-value method. The other one is critical value method. Okay, critical value method. Now, so p-value method, we find the p-value. Okay, so this is test statistic. And then, so p-value will be negative 2.9. I mean, negative 0.29. So this is negative because this is 0. This point is negative 0.290. Close enough. Okay. So this area is p-value. So if you go all the way to the left, what do you have? Negative 9999999. So how to find this area? So this is how to find the area. Go to calculator. Okay, go to calculator here. And then I'm going to clear everything. Now go to second bars. We don't use inverse norm. Now we use TCDF. Everybody has that. If TI-84, TCDF. You click enter. And then small is negative 999,999. Bunch of nines, right? You get 6 or 7. Comma. What is it? What is a upper? Negative 0.29. Okay. And then this is what you need to do. TCDF lower, upper, and then degree of freedom. Degree of freedom is n minus 1. N was 12, so minus 1, which is 11. So there goes 11. So back to the calculator again. So now I have to comma degree of freedom. What was it? 11, I said. 11. Okay. So when you hit enter, you get 0.3886. So this area is 0.3886. This area. Okay. That is p-value. Area is p-value. This p-value is greater than alpha. Alpha is 0.05. Okay. If you look at the question. If you look at the question, alpha is here. They're gonna here. Alpha is significant level. 0.05 significant level. 0.05. Okay? That's what this 0.05 is. Now, so this is p-value. This is significant level. Now, so what we're going to do? Number 6 is we're going to what? Fail to reject null hypothesis because what? P-value is greater than alpha. So it's supposed to be, what case supposed to be? Case supposed to be 3 or 4. We fail to reject. Okay, we're gonna fail to reject because p-value is bigger than, because p-value is greater than alpha. So we go to case 4. What case was says? Not sufficient evidence to support the claim. Okay, so go back. So not sufficient evidence to, so here, so case, so 7 is final conclusion. Okay, so this is case 4, right? Case 4. So not sufficient evidence to support the claim of mu is less than 7. Okay, although number of hours they sleep. Okay, go back to the textbook. Number of hours, if you look at it, there are so many hours less than 7, okay? But there are some numbers greater than 7, okay? So you cannot really conclude from this data the sleep number of hours is less than. You cannot support that claim. That's what it means, okay? So that was done by p-value method. What is a critical value method? Critical value method is alpha significant level is 0.05 and it is left tail test, okay? So now, so 0.05, this area is 0.05 because left tail. This is critical value. This is 0. So how to find this critical value? So you go to calculator. This time, when you do 8.3 to find critical value, you go to second bars. This time, be careful. You go to inverse t, okay? Inverse t, and then 0.05 inverse t, and then area, comma, degree of freedom. So in this case, inverse t 0.05, comma 11. Okay, so you do 0.05 already did it, comma 11. Okay, then they give you negative 1.79. So critical value is back here, negative 1.796, negative 1.796. But what is our test statistic? Our test statistic is negative 0.29. So negative 0.29 is right there. Okay. So test statistic is not. We failed to reject null hypothesis because test statistic, which is negative 0.29, is not in the critical region. This area is the critical region, okay? And because of that, we failed to reject, so this is going to be case 4. So same conclusion, not sufficient evidence to support the claim. Same support the claim of, what was the claim? Mean amount of sleep is less than 7. Okay, should be the same conclusion. Okay, so one is critical value method. This was p-value. This was critical value. Okay, you can always test using one of those two. Okay, so now let's go back to the textbook. Okay, so if you read the final conclusion here, because p-value is greater than significance level, okay, 0.3887 is greater than 0.05. That's what it means. We failed to reject null hypothesis, okay? Because we failed to reject null hypothesis, we conclude there is not sufficient evidence to support the claim. The mean sleep is less than 7 hours. Okay, we cannot support that. Okay, so that is how to do with p-value. They also did critical value. We just did that. Critical value, remember? We did. Okay, let me just move it over here. So critical value was that, and then we did we did critical value. Remember this? Okay. So critical value, we find critical value. What was critical value? Critical value was negative 1.796. Negative 1.796. Okay. And then our test statistic was negative 0.29. This area is critical region. Okay, our test state is not in the critical region because it is over here, right? So you can see that that's how they did it. Now we're not going to do confidence interval method. Okay, so let's look at one more example. Okay, one more example, which is here, example 5. Is body temperature really 98.6? Okay, so if you see the data set in this textbook, they check 106 people and they check their body temperature, and mean body temperature is 98.2, and then standard deviation was 0.62. So based on this one and using 0.05 significance level, can we say that mean body temperature is 98.6? That is the question. Is mean body temperature is 98.6? Okay, so let's do the testing here. Okay, so here, so let me move over here. Oops, come on. All right, so now let's just move it up. So claim. Okay, always start with 7 step. So number 1 is the claim. Claim is mean body temperature is 98.6. Now it has equal sign. So this is case 1 or case 2. It has equal sign. Claim has equal. Check this wording. Okay, here. What is it? Does original claim contain the equality? Now we go yes. If you go yes, it has to be case 1 or 2. Okay? Because yes, you're going to go end up in either this one or that one. If the first one is case 1, second one is case 2. Okay? So now, okay, here. So now, so that's the claim. So it is case 1 or 2. I just explained to you why it's case 1 or 2. Now, it matters because case 1, 2 different from case 3, 4. Okay. So now null hypothesis is mu equal 98.6. Null is this called null hypothesis. Null is always equal. Okay. Null hypothesis. Okay. And then alternative hypothesis. Now this is important. Alternative hypothesis is not equal. Okay. Let me write here. If claim contains equal, H1 is not equal and becomes two-tailed test. Okay, remember, very important. It's not left tail, it's not right tail, it's a two-tailed test. Two-tail. Okay, two-tailed test. Okay, so it becomes two-tailed test. If it's not equal, it's two-tailed. Now, so number 4 is test statistic. Test statistic is x bar minus mu divided by s divided by square root of n. Okay, so x bar is 98.2, mu is 98.6, s is 0.62, n is 106. You need this information. Okay, now you find test statistic. So this x is 98.2 minus 98.6 divided by 0.62 divided by 106. Okay, so to do that in the calculator, okay, here. Now I'm going to turn on the calculator. Let's bring it up here. So 90, let me clear that. 98.2. Subtract 98.6. Divide by parenthesis 0.62. Divide by square root of 106. Okay, so two parentheses, close. And then your test statistic is negative 6.64. So this is negative 6.64. Okay, now if you look at it here, you get negative 6.64. Okay, now, and then you have to test. You have to, test the claim. Number 5. One is p-value method. The other one is critical value method. Okay. Now, p-value negative 6.64. This is very far away, negative 6.64. P-value is 2 times the area. Why 2 times? Because it is two-tailed test. Okay. So this is area. What is the area? If you go all the way, negative 999,999, okay? So, to take the calculator out, okay? And then I'm going to find the area. I'm going to clear that. So what you need to do, go to second bars, and then this time you go to TCDF. Remember that? TCDF. So you do TCDF, lower, upper degree of freedom. So in this case, TCDF, lower is negative 999,999, upper is negative 6.64. Degree of freedom, N is 106. Then degree of freedom is 106 minus 1, 105. So you got to put 105 in the calculator. So let's put those. Okay. So TCDF I said, hit enter, and then negative 999,999, comma, negative 6.64, comma, 105. Okay, so when you enter, you have that area, but this area, so this is 2 times, what is this area? 7.09 negative 10, okay, 7.09 times negative 10. I mean, if you put here, negative 10. What that means, you have 0.00000000090 and 709. 90 because negative 10. Okay? So this is pretty much 0. So this is 2 times 0 is like a 0. Okay? When you round to how many decimal, it's 0. So now, what do? P-value is almost 0, is less than alpha, which is 0.05. Okay? And then when p-value less than alpha, what do? You reject the null hypothesis. Okay? Then, case 1. Why case 1? Remember, you go to wording. Do you reject? Yes. Why reject? Why reject? Because p-value is less than alpha. If a p-value is greater than alpha, then fail to reject. But p-value less than alpha, in this case, we go to yes. What is case 1? Sufficient evidence to reject the claim. Okay, so we go. Final conclusion is sufficient evidence to reject the claim of what was claimed? Mean body temperature is 98. What was the claim? This is the claim. Okay, it's important to know the claim. Mean body temperature is 98.6. That's the claim. We're going to sufficient evidence to reject the claim. 98.6. We're going to reject that. Okay. So that is how to do with p-value. Critical value is, critical value is p-value. Alpha is left tail test. This two tail test, right? So two tail test. Alpha equal 0.05. In two tail test, to find the critical value, you divide this guy by 2. This one by 2. So each area is 0.025. I know it's a little confusing, but there's nothing I can do about it. That's the way it is. So you have 2 critical values. One is positive, one is negative. Okay, why? Because it is what tail test? What tail? What tail? Because it is 2 tail test. Then you divide alpha by 2. That's why you got 0.025 each. So to find critical value, let me erase that part now. So to find the critical value, you go to calculator, okay, and then go to second bars. Now you go to TCDF, okay, TCDF, and then you find the area 0.025, and then degree of freedom, remember, TCDF, okay, 0.025, and then degree of freedom, okay. So this is a 105. This is 105. Okay. So you put that numbers in the calculator, 0.05 and 105. Okay. And they give you, oops. You're gonna find the area, right? Oh, not TCDF. Sorry about that. Second bars. It is inverse T, okay, inverse T, sorry about that. So it's not TCDF, it is inverse t. Okay, so go to inverse t. Come on. So let me clear that. Inverse t, second bars, inverse t, and then 0.025, comma 105. Okay. Then you get negative 1.98. So this is negative 1.98. This is positive. You always have a two critical value in two-tailed test. But what is our test statistic? Test statistic was negative 6.64. So negative 6.64 is in the critical region, remember? Okay. Is in the critical region. So this is 5, 6. We reject the null hypothesis. Null hypothesis because what? Test statistic is in critical region. So this is case 1. Okay, so case 1 is the same. You have to state the same thing here. Okay, all right, that's it for this lesson. Okay.